Alright, let us now work on the concept of cube and cube roots. If you take any number m and you multiply 3 times, okay, then what you get as a result is m to the power 3, correct? When you get that, then it is called as cube of m, okay? And if this happens to be a natural number, right? And we know what natural numbers are. Natural numbers are number bigger than 1. If m happens to be a natural number, then the cube of a natural number is called a perfect cube. It rhymes with the definition of the perfect square that for example, when you took a number m, and if m happened to be a natural number, and when you squared it, what you obtained as a result was a perfect square, correct? You remember the definition, right? And cube is just like that. Instead of raising the power 2, we are raising a power of 3 to the natural number, okay? And this is what is known as perfect cube. Okay, so given that, now let's take another number p, okay? And you raise it to the power 1/3. What you obtain as a result is called cube root. And it can also be written as p inside the root operator, and then we write a number 3 that signifies that it is a cube root of the number p. So for example, if I take the number 2, when I multiply 2 3 times, I get 2 to the power 3 and it is 8. Hence, it is said that cube of 2 is equal to 8. Alright. At the same time, when I take the same number 8 and I raise it to the power 1/3, and right from here we can say that 8 is equal to 2 to the power 3, right? And 1/3 of that becomes 2 to the power 3 times 1/3, which is equal to 2. It means that 2 is a cube root of number 8. Okay, so that is the linkage between the cube and cube root. Okay, just like what we had a square and a square root. Okay, so given this knowledge of cube and cube root, the next question, the same question that we had in perfect square, is that when you are given a number, how do you really identify that a number is a perfect cube or not? So the task is how to identify perfect cubes. Okay, so we'll discuss that in our next few minutes. So my first example is, let's take a number 1000. Okay, I want to find out if 1000 is a perfect cube or not. What I can do is, I can simply divide this number into 3 pieces, such as 10 times 10 times 10. It is an easy number, that's why I took it for a reason, that it can be written as a product of 10 3 times, or it can be written as 10 to the power 3. Okay, so whenever you can write any given number, such as 1000 in this case, into a multiple of smaller numbers, such as this, such that the smaller number, the base number, becomes a whole number, and in this case 10 is a whole number, then we say that 1000 is a perfect. So let's take one more example. The second example is the number 3375. Now this number is slightly complex as compared to 1000. It was very easy to see 1000 can be written as a product of 10 times 10 times 10. But what will you do when you are given a number like this? Then we will utilize the same method that we utilized in finding the perfect squares, that you take that number and divide this into its prime factors. And 3375, I notice that it has a 5 in its units place. That means it is divisible by 5 for sure. So I will start with 5, and when I divide 3375 with 5, I get 675 here. 675 can further be divided into 5, and 675 divides into 135, which further divisible by 5 gives you 27. 27 can be divided into 2 parts like this, and there you go. So we have to stop here now because this cannot be divided any further. So in essence, what do you see here? What I see is that 3375 can be written as a product of 5, and how many 5s are there? 1, 2, and 3, right? So 5 to the power 3 times 3 to the power, how many? How many 3's are there? I have 1, 2, and 3. So 3 to the power 3, right? So 3375 can be written as a product of its prime factors, and there is a triple of each prime factor, right? 5 to the power 3 and 3 to the power 3. And that is what will tell you whether it is a perfect cube or not. If a number such as this can be divided such that each one of its prime factors, such as 5 and 3, exist in its triplets, then we can say that this is a perfect cube. That's all we are looking for. All right. It is exactly the same method as we have done previously in the perfect squares. Divide a number into its prime factors. So this is the key, dividing into prime factors. Identify that each one of the prime factor can exist in triplets. Okay. And if it does, then it is a perfect cube. Okay, so in next tutorial, we are going to talk about how to find the cube roots of any large number.